Howdy. Section 7.6 is about exponential functions, and basically that means that your x is an exponent. That means that your x is the exponent of something. And so in a function notation with the x, and that's what it looks like. If you're just looking at a series of numbers like that, well, what you look for is to see if you're multiplying by the same thing each time. So that's times 2, that's times 2, that's times 2, that's times 2. So that is an exponential function because it is multiplied by the same number each time. So you're looking for a multiplied by the same number each time for it to be an exponential function. If it's a function notation, you look for the x up there. So a couple of problems will ask you, is this an exponential function? If it gives you a list of numbers, just divide consecutive numbers and see if it's always the same. If they give you function notation, just make sure the x is in the exponent. And that's all we're going to say about that. So multiply by same each time, by the same number each time. That pound sign means number. It's a good way to write your notes a little faster. And down here, if the x is an exponent. If the x is the exponent. So those are the two things you're going to look for. Let's look at graphing. We're going to graph an exponential function. So let me scooch this down a little bit. Okay, some of these problems, let's see, they'll say y equals 2 times 3 to the x power. So we're going to make a little table from -2 to 2. So this is 2 times 3 to the -2 power, 2 times, I'm just going to write out these first, 2 times 3 to the first power, and 2 times 3 to the second power. Okay, and those positive exponents are actually easier to work with because we've done more with those over time. So I know 3 to the second power, that is 9 times 2, that's going to give me 18. 3 to the first power, that's just 3 times 2 is 6. Remember, anything to the 0 power is 1, so 1 times 2 gives me 2. Okay, there are a couple ways you could approach these next couple numbers. You could attack it directly, put the 3 in the denominator. So this means 2 over 3 to the first power. And this is the negative exponent also. It means put that in the denominator. So it'll be 2 over 3 to the second power. And then figure those out. The other way you could do it is just to continue the pattern here. I divide by 3, divide by 3, divide by 3 again. And that will give you that answer. So you could approach that a couple of different ways. I think directly attacking it is the easiest way for me to show you, though. I'm getting my calculator at this point. So this is going to be 2 divided by 9. That is 0.222 repeating. And 2 divided by 3 is 0.6666 repeating. Forever and ever and ever. Okay, what I'm going to do now is graph these points. So I'm going to graph the point 2, 18, the point 1, 6, the point 0, 2, negative 1, 0.6, negative 2.2. I'm going to graph those 5 points. So I'm going to scooch my paper over a little. All right. So I have to go up, let's say I'm going to count by 5s. So 5, 10, 15, 20. Spread out my x-axis a little bit. That's 1, 2, 0, negative 1, negative 2. Okay, however you set up the scale is fine, as long as you get the points there. So 218 would be right about there. 1, 6, right there. 0, 2. And these next ones are going to be really close to the axis. Negative 1, 0.6, negative 2.2. And so this is what my graph will look like. So it's going to be kind of a curve that's flattening out. And if you can imagine, as I keep dividing by 3, it'll always get smaller, but it'll never actually become negative. If I keep dividing by 3 again and again and again and again and again, it will never give me a negative number. So don't go over the x-axis, it just gets really close. Okay, so this is a graph of an exponential function. Okay, I want you to go ahead and try one. Go ahead and try to graph that one there.